Good afternoon, students. Today we'll move to the next part of electricity. So we learned about electricity, types of electricity, electric current, electric potential, potential difference, their symbols, their SI units. You have to be perfect in all these categories. Okay. And today we'll learn about circuits. Okay, electric circuit and how the symbols are represented. So what is electric circuit? So this is an electric circuit. This is an electric circuit. Okay. Suppose if I say a meter, this is positive and negative, and a bulb will be there. Okay, and a key will be there. This is a normal electric circuit. I will explain all these key, bulb, and everything later. So this is plus and this is minus. So what is electric circuit? Here the current is flowing. So on that we have to define electric circuit. What is electric circuit? A continuous. This is continuous. Current is flowing continuously. A continuous and closed path. Closed path means there is nothing, is no opening. So there is a flow for current. Current can be flow without any disturbance. Okay, there is no cut. Okay, that means it's a closed path. A continuous and closed path of electric current. A continuous and closed path of electric current is called electric circuit. What is electric circuit? The continuous and closed path. It is a continuous path and it is closed also. There is no open, there is no opening. So it is a continuous and closed path of electric current is called electric circuit. A continuous and closed path. It should be closed path and it should be continuous path. So you can use the here. The continuous and closed path of electric current is called electric circuit. So what is electric circuit? The continuous and closed path of electric current. Whose path it is? It's electric current's path. Because electric current is moving. Electric current is moving because of flow of electrons. Electric current is generated. That electric current is moving from positive to negative. That is the conventional direction of electric current. If anyone asks, what is the direction of electric current? Always from positive to the negative of the battery, or positive to the negative of the cell. That is conventional flow of electric current. Okay. So now in this diagram you are seeing battery, you are seeing ammeter, you are seeing bulb, here you are seeing. So we learn about those circuit symbols now. So what we call them as circuit symbols. Okay. We learn about those circuit symbols. Okay, how they are represented. So first circuit symbol. What is first circuit symbol? See, this is battery. This way we represent a battery. This is cell, plus minus. What we call it as cell. Cell is represented by this. Okay, cell, one plus is there, one minus is there. Okay, this is cell. And one question will be asked: which kind of energy is stored in cell? Remember, the cells you are using in your home, there is one positive and one negative. Their chemical energy is stored in that. You have to remember, cell, the energy present in cell is chemical energy. Okay, and if many cells are combined, we call it as battery. We call it as battery. What is battery? Combination of two or more cells. If many cells are combined, we call it as battery. So we can say like this: this is the battery. It should be connected properly. They should be connected properly. So this is battery, plus minus. Here one cell, here one cell, here one cell. Three cells are connected. There is no such rule that only three cells are connected. It can be two cells also. It can be four cells also. So combination of cells is called battery. So question might be asked, define battery. Battery is nothing but combination of two or more cells. A combination of two or more cells is called as battery. Okay. Third one. What is third one? So third one is bulb. Third one is bulb. How we represent bulb in an electrical circuit is like this. If we represent this we call it as bulb. This is bulb. Bulb is the representation. Fourth one. Okay. What is fourth one? See, you will see a representation like this. Okay. Representation like this. These both are wires. So we call this as wires without any crossing. Wires without any cross. Without any crossing. Okay, you can say it as wires without any crossing. Okay, these four you have to remember. Remember these four: cell, battery, bulb, and wires without any crossing. In next we will go to remember this. Next we will go to fifth one, that is wire joint. Wire joint. That will be like this. A wire will be there, another wire will be this side. So this is the joint. So okay, it is wire. So this joint with a different color I am making, this is called wire joint. Okay. Next one is resistance. What is resistance will come in the next concept. So resistance will be like this. Okay, this is the resistance of resistor R. Okay, it is the resistor or a resistance, you can say resistor of resistance R. So it is constant resistance. Another one will come, that is variable resistance, or another word for this is rheostat. We say variable resistance. Okay, this is the symbol. Okay, we can use like this, or variable resistance can still be done like this. Okay, both are variable resistance. Another word for this is rheostat. You can use another word, rheostat. What is the difference between these two resistance? Here the resistance is fixed. For example, resistance 10 ohm is there. Okay, it is fixed for that circuit. But here it can be varied. The 10 ohm resistance can be varied by rheostat to 9 ohm, 8 ohm, 7 ohm or 12 ohm, 13 ohm. It can be increased or decreased depending upon the condition of circuit. Okay. So here it can be changed. Here it cannot be changed. So it's a constant resistance. This is a variable resistance. You have to remember these. These are present in book also, but you still remember these. This is variable resistance. This can be represented like this or like this, or this is a variable resistance, or another name is rheostat, and constant resistance is represented like this. Okay. So after this, another two are there. Okay, which you already know. Ammeter. Ammeter A, like this, it will be plus and minus. And ammeter is always connected in series with the circuit. Series in the circuit. Another one is voltmeter. How we represent voltmeter? Similar way, but voltage will come plus minus like this. So voltmeter is always connected in parallel, in which we are measuring the voltage. Usually it is connected in parallel with resistor or bulb. It is connected in series with resistor or bulb. Okay, this is up to this much. Okay, another two are there. So what we call as key or switch. Key or switch. Okay, if it is open, it will be like this. This is key or switch open in the parenthesis. Okay, common bracket we call. And if key or switch is closed, key is closed or switch is closed, this is we will represent like this. This is key or switch is closed. This is key or switch is open. Key or switch is open like this. Key or switch is closed will be like this. Okay, these are regarding the circuit symbols. You have to remember all these circuit symbols. Don't forget wire joint, resistance, variable resistance, ammeter, voltmeter, key or switch open, key or switch closed, and the earlier 3 we have seen. Earlier 4 we have seen. That is cell, battery. Okay. So what is cell? What is battery? You have to remember. What is battery? Battery is the combination of 2 or more cells. So that is battery. So after this circuit symbols, you can pause the video and check out all the symbols once again. Please pause the video and check out all the symbols once again. So as we know, see, if there are 2 tanks, okay, if there are 2 tanks connected by a pipe, if there is difference between the water is less, definitely speed of the water will be medium. If the difference is medium, this is water tank 1, this is water tank 2. Okay. Here the difference is less. Up to this much is there, this much here. Only this much is the difference. Okay, this is the difference. That time the flow of water is medium. Suppose if I increase this difference, suppose it is filled and it is another one is almost empty. Means if I have put only water up to this much. So now the water will flow more, right? Now the water will flow more. Do you agree? Here the flow of water is more because the difference between the potential of water is more. So if the potential or the amount of water present in tank 1 and tank 2 whose difference is more, then the current will be more. That means flow of water will be more here. Here also flow of water will be more. Same thing will apply to electrons or potential difference. Similarly, that means the voltage or potential difference. So suppose if I say these are electrons, instead of water we will take electrons. Here the flow of electron is medium, here the flow of electron is more. This is more compared to this. Okay, medium or say less. This is, so here in situation 2, S2 or S1. In situation 2, current is more, that is I2. I2 is more compared to I1. That means what? Here difference is less. What is difference? Electron difference. Electron difference is nothing but potential difference. Potential difference is less. Here potential difference is more. So as the potential difference is less, current is less. As the potential difference is more, current is more. That means potential difference decides the current. That means if the potential difference is more, current is more. If the potential difference is less, current is less. So potential difference is directly proportional to current. That is V is directly proportional to I. So this proportional symbol is removed by taking one constant V equal to Ri. This R is called as the resistance of a conductor. So V equal to IR. This is called as Ohm's law. What is Ohm's law? The formula for Ohm's law is V equal to IR. So definition of Ohm's law. Ohm is a scientist who has more knowledge on this resistor, okay, and current. So how to define? Check out this. This is what? Potential difference. This is directly proportional symbol. This is current. The potential difference in a circuit is directly proportional. The potential difference across the terminals of a circuit is directly proportional to the electric current flowing through it, provided its temperature remains constant. Here the temperature should be constant. Temperature must be constant. Okay, how to define? I will tell you once again. The potential difference between across the terminals of a conductor is directly proportional to the electric current flowing through the circuit provided its temperature remains constant. I will write it. The potential difference across terminals of a conductor is directly proportional to the current flowing through it at constant temperature. Provided temperature remains constant, or you start with at constant temperature. At constant temperature. At constant temperature, the potential difference across terminals of a conductor is directly proportional to the current flowing through it. That means current flowing through the circuit. So this is regarding Ohm's law. Okay, V equal to IR is the formula. R is the resistance. What is resistance and what are its properties? How it is used? We have seen the next class. But in this class, you just remember Ohm's law. So formula for Ohm's law is V equal to IR. V is voltage, I is current, R is resistance. So I is dependent on both resistance as well as voltage. If the voltage increases, I increases. If the resistance increases, I decreases. Resistance is reverse to current. Okay. So resistance is opposition to the flow of current. So resistance is exactly opposite to the current. But voltage and current are directly proportional. So you have to remember Ohm's law. What is Ohm's law? At constant temperature, the potential difference, or you can say voltage, both are same. The potential difference across terminals of a conductor. See, always potential difference is taken across the terminals. See, this is the terminals. These two are terminals. Like this. Any 2 points we take. Not only these 2 points, any 2 points we will take it as across the. Okay. The potential difference across the terminals of a conductor is directly proportional to the electric current flowing through it at constant temperature. Or initially you start at constant temperature, the potential difference across the terminals of a conductor is directly proportional to the electric current flowing through it. This is called Ohm's law. Okay. So regarding this, V equal to Ri and V equal to IR is the formula of Ohm's law. You have to remember this formula because this formula will be used in solving numericals. So regarding resistance and factors on resistance depends, we will see in the next class.